In question 1, we have a number of statements. We have these 8 statements that you see here, and for each of the statements, we have to specify whether the statement is true or false. So for each statement, I will help you visualize what that statement says through a figure, and then we will decide whether the statement is true or false. So the first statement is all rectangles are squares. So do you think this statement is correct or not? Well, if you take any general rectangle, the adjacent sides of the rectangle may not be equal, but in a square all the sides are equal. So all rectangles are not necessarily squares. So the first statement is false. Okay. Now let's go to the second statement. The second statement says all rhombuses are parallelograms. So what is a rhombus? A rhombus is a figure like this, which is basically any parallelogram in which all the 4 sides are equal. So by definition, a rhombus is a parallelogram. So the second statement is true. All rhombuses are parallelograms. Now let's go to the third statement. The third statement is all squares are rhombuses and also rectangles. So imagine a square like this, like the one I have drawn here. Now by definition, a square is a parallelogram in which all sides are equal. So a square is a rhombus, and also in a square all the angles at all the vertices, they are all 90 degrees. So a square is also a rectangle. So because all sides of a square are equal, it is a rhombus, and because all angles of a square are 90 degrees, it is also a rectangle. So the third statement, that all squares are rhombuses and also rectangles, this is also true. Now let's go to statement 4. Statement 4 says all squares are not parallelograms. So once again, imagine a square. By definition, a square is a parallelogram in which all sides are equal and all angles are 90 degrees. So this statement, statement D, is clearly false, because all squares, any square must also be a parallelogram. Alright, now let's go to statement E, which says all kites are rhombuses. Now what is a kite? Okay, here's a figure, here's an example I've drawn for a kite. A kite is a quadrilateral in which one pair of adjacent sides are equal and the other pair of adjacent sides are also equal. So we have one pair equal with each other, and the other pair of sides are equal with each other, but all the 4 sides may not be equal to each other. So all kites cannot be rhombuses, because a rhombus is a parallelogram in which all the 4 sides are equal. A kite may not even be a parallelogram. So the statement E is false. All kites are not rhombuses. Alright, now let's go to statement F. Statement F says all rhombuses are kites. What is a rhombus? A rhombus is a parallelogram in which all the 4 sides are equal. So a rhombus satisfies all the conditions of being a kite. We have one pair of adjacent sides equal. We have the other pair of adjacent sides also equal. So a rhombus is a special case of a kite in which all the 4 sides happen to be equal. So statement F is true. All rhombuses are kites. Then statement G says all parallelograms are trapeziums. So what is a parallelogram? A parallelogram is a quadrilateral in which both pairs of opposite sides are parallel to each other like this. And a trapezium is a quadrilateral in which at least one pair of sides should be parallel to each other. So because a parallelogram has both pairs of sides parallel to each other, it is a special case of a trapezium. So the statement in G, part G, is true. All parallelograms are trapeziums. And finally, let's go to statement H, which says all squares are trapeziums. So a square is a parallelogram, and we just saw in the previous statement that all parallelograms are trapeziums. So all squares must also be trapeziums. Specifically, because in a square we have both pairs of sides being parallel to each other, we can see that a square is also a trapezium. So statement H is also true. And this completes question number 1. In question 2, we have to identify all the quadrilaterals that have 4 sides of equal length, and 4 right angles. Now this is a very interesting question because it helps us think deeply about various kinds of parallelograms. And what I will do is that I will use a couple of simulations from QMath Leap to help you visualize the ideas in this question more effectively. Okay, so we have to identify all quadrilaterals that have 4 sides of equal length and that have 4 right angles. Let's start with the first part, quadrilaterals with 4 sides of equal lengths. Okay, so here's a simulation which shows a quadrilateral ABCD that has 4 sides of equal lengths. The length of each side of ABCD is 5 units, and we can immediately see that ABCD is a parallelogram, and more specifically it is a rhombus because all of its 4 sides are equal. Now let me move around the vertex D, and as I do this, as I move around the vertex D, observe that all the 4 sides stay equal, so the quadrilateral is always a rhombus. So quadrilaterals which have 4 sides of equal lengths are all rhombuses. But there is also a special case of rhombuses. Rhombuses in which the adjacent sides are perpendicular. Let me move the point D, the vertex D, so that AD becomes perpendicular to AB, like this. So AD has become perpendicular to AB. Now what kind of rhombus is ABCD? Well, ABCD is a square because all of its sides are equal and all of its angles are also equal to 90 degrees. So squares are a special type of rhombuses with 4 sides of equal lengths. Alright, so to summarize the answer to the first part, quadrilaterals with 4 sides of equal lengths are all rhombuses, and a special type of rhombuses are squares. Now let's do the second part, quadrilaterals with 4 right angles. Okay, so here's a simulation which shows a quadrilateral ABCD that has 4 right angles, and we can immediately see that ABCD is a parallelogram, and more specifically it is a rectangle because all of its angles are equal to 90 degrees. Now let me move around the vertex D, and as I do this, observe that the 4 angles all stay equal to 90 degrees, so the quadrilateral is always a rectangle. So quadrilaterals which have 4 right angles are all rectangles, but there's also a special kind of rectangles in which the adjacent sides are equal. So let me move the point D so that AD becomes equal to AB. So AB is 7 units, so let's make AD also equal to 7 units like this. Now what kind of rectangle is ABCD? Well, ABCD has now become a square because all of its sides are equal and all of its angles are also equal to 90 degrees. So squares are a special type of rectangles with 4 right angles. Alright, to summarize the answer to the second part, quadrilaterals with 4 right angles are all rectangles, and a special type of rectangles are squares. And this completes our discussion of the second question. Question 3 says, explain how a square is a quadrilateral, a parallelogram, a rhombus, and a rectangle. So this is actually a very straightforward question. Let's consider any arbitrary square. So here I've taken this square ABCD that you see, and let's figure out why this square should be a quadrilateral, a parallelogram, a rhombus, and a rectangle. So the fact that a square is a quadrilateral is easy to see. A square is a 4-sided polygon, and any 4-sided polygon is a quadrilateral. So a square will surely be a quadrilateral. So part 1 was straightforward. Now in part 2 we have to specify or explain why a square should be a parallelogram. Well, in any square, opposite sides are parallel. So AB will be parallel to DC and AD will be parallel to BC. So in a square, opposite sides are parallel, and this means that the square must also be a parallelogram. So that does part 2. Now in part 3 we have to describe we have to explain why a square is also a rhombus. So we have shown that a square is a parallelogram. The other thing about a square is that all of its four sides are equal. So AB is equal to BC is equal to CD is equal to DA. So a square is a parallelogram in which all sides are equal. So any square is a parallelogram in which all sides are equal, and this means that any square will also be a rhombus, right? So that explains part 3. And then finally in part 4 we have to explain why a square is also a rectangle. Now a rectangle is a parallelogram in which all the angles are 90 degrees. So that is also true for a square. In a square, all the four angles at the four vertices, they are all equal to 90 degrees, and hence and because of this fact, all angles in a square are 90 degrees. This means that a square will also be a rectangle. So a square is a quadrilateral, it is a parallelogram, it is a rhombus, and it is also a rectangle. And that completes question number 3. In question 4, we have to name the quadrilaterals whose diagonals bisect each other, are perpendicular bisectors of each other, and are equal. So let's start with the first part, the quadrilaterals in which the diagonals bisect each other. So what are those quadrilaterals? Quadrilaterals in which the diagonals bisect each other. Well, those quadrilaterals are parallelograms, because we know that whenever in a quadrilateral, if the diagonals bisect each other, the quadrilateral must be a parallelogram, because the diagonals in a parallelogram bisect each other. And this means that specific kinds of parallelograms will also be quadrilaterals in which the diagonals bisect each other. For example, if you take rectangles, squares, or rhombuses, these will all be quadrilaterals in which the diagonals will bisect each other. So the answer to the first part is the quadrilaterals in which the diagonals bisect each other are parallelograms, rectangles, I'm just writing the short forms, rectangles, squares, and rhombuses. So this is the answer for part 1. Now in part 2, we have to name the quadrilaterals in which the diagonals are perpendicular bisectors of each other. So if the diagonals are bisectors of each other, we know that the quadrilateral must be a parallelogram, but we want the diagonals to be perpendicular bisectors of each other. So in which kind of parallelograms are the diagonals perpendicular to each other? Well, in rhombuses, the diagonals are perpendicular to each other, and because they also bisect each other, in any rhombus, the diagonals will be perpendicular bisectors of each other. So quadrilaterals in which the diagonals are perpendicular bisectors of each other are rhombuses. And there is a special type of rhombuses. What is that special type? Well, that special type is squares. So you take any square, because any square is also a rhombus. A square will also be a quadrilateral in which the diagonals are perpendicular bisectors of each other. So we can also add a square as the answer for part 2. So this completes part 2. Now in part 3, we have to specify or name the quadrilaterals in which the diagonals are equal. So one class of quadrilaterals in which the diagonals are equal are rectangles. Rectangles are parallelograms in which the diagonals are equal to each other. So one of the answers for part 3 could be rectangles. And we also know that squares are special types of rectangles. So even in a square, even in any square, the diagonals will be equal. So we can also add squares to our answer. So rectangles and squares are examples of quadrilaterals in which the diagonals are equal. And in the NCERT textbook, these are the only 2 answers which are specified. But the thing is that you can also have other kinds of quadrilaterals in which the diagonals are equal. And let me show you an example of that. So let's draw a quadrilateral ABCD in which the diagonals AC and BD are equal, but ABCD is not a parallelogram. To do this, first draw a segment that represents the diagonal AC. So let's say that this is the diagonal AC. And now let's draw another segment BD that is equal to AC, but the two are not bisectors of each other. So let's say that we draw BD like this. So BD is equal to AC, but AC and BD, as we can see, they do not bisect each other. And now let's take these 4 points A, B, C and D, and let's join these 4 points to complete the quadrilateral ABCD. So we have A, B, C and D like this. So we see that in ABCD, the diagonals AC and BD, we have drawn them to be equal, and yet ABCD is not a rectangle, it's not a square, it's not a parallelogram. So for part 3, we could have other kinds of quadrilaterals apart from rectangles and squares in which the diagonals are equal. But the answer in the NCERT textbook is only rectangles and squares. But I just wanted you to be clear that we could have other kinds of quadrilaterals as well. So this completes part 3, and with this we have completed question number 4. Question 5 says, explain why a rectangle is a convex quadrilateral. So what does this term mean, convex quadrilateral? In general, what do we mean by a convex polygon? Let's start by discussing that. The meaning of a convex polygon. A convex polygon is any polygon for which all diagonals lie in the interior of the polygon. Any such polygon is a convex polygon. Let me show you a couple of examples. So take a look at these two polygons that you see, the one on the left and the one on the right. The one on the left is a convex polygon because if you draw any diagonal in this polygon, for example, if you join the vertex here to the vertex here, or if you join this vertex to this vertex here, the diagonals will lie completely inside the polygon. So this polygon on the left is an example of a convex polygon. But if you look at the polygon on the right, and if you join the vertex here, this vertex to this vertex here, then you can see that this diagonal, it lies outside the polygon. And this is happening because this vertex here, the angle at this vertex is a reflex angle, and hence this diagonal, it lies outside the polygon. So this is an example of a non-convex polygon, which we sometimes also refer to as a concave polygon. So this question is about explaining why a rectangle is a convex quadrilateral. And now after this discussion, the solution should be quite straightforward. Let's look at any rectangle. Let's take this rectangle ABCD. Now there are only two diagonals we can draw in this rectangle. So we have the diagonal AC and we have the diagonal BD. And we can see that both of these diagonals will lie completely inside the rectangle. So let's write out this reason. Both diagonals of any rectangle lie inside that rectangle. And this is the reason why any rectangle will always be a convex quadrilateral, because both of its diagonals will lie inside the rectangle. So that completes question number 5. Question 6 says that ABC is a right angled triangle and O is the midpoint of the side opposite to the right angle. So ABC in this figure is right angled at B, and this point O, it is the midpoint of AC. So OA is equal to OC. So OA is equal to OC because O is the midpoint of AC. And then the question says, explain why O is equidistant from A, B and C. So the fact that O is equidistant from A and C, that's obvious because O is the midpoint of AC. But we also have to prove that O is at the same distance from B as well. So basically we have to prove that this distance OB is also equal to OA and OC. So we have to prove that OA is equal to OC is equal to OB. This is essentially what we have to prove. And then the question says the dotted lines are drawn additionally to help you. So do you see these dotted lines AD, OD and CD? So let me explain to you how these dotted lines have been drawn. So let's first imagine the situation when these dotted lines were not present. So the situation would have looked like this. Now what basically the question has done is, that from the point A, a parallel has been drawn to BC, and from the point C, a parallel has been drawn to BA. And this is how we get these dotted lines. So from A, we have drawn AD parallel to BC, and from C, we have drawn CD parallel to BA. So this is how we get these dotted lines, and these two rays meet at the point D, and then we have joined O and D to get this segment OD. Now let's talk about how this construction will help us prove this fact that OA and OC are both equal to OB. Now what this construction has done is that it has given us this parallelogram ABCD. And why is that? Because we have drawn AD parallel to BC and AB parallel to DC. So both pairs of opposite sides in ABCD are parallel to each other, and this means that ABCD is a parallelogram. Also, one of the angles in ABCD is 90 degrees. This angle here, the angle at B, is 90 degrees, and this means that all the other angles of ABCD will also be 90 degrees. So the fact that angle B is equal to 90 degrees ensures that all the angles of ABCD will be 90 degrees. So ABCD will be a rectangle. And now this is quite awesome because this helps us conclude this result quite easily. And how is that? Well, we observe that one of the diagonals of this rectangle ABCD is AOC, this side, this segment AOC. So AOC is one diagonal of the rectangle. And what about the other diagonal? So if we join the points B and D, they should also pass through the midpoint of AC, because the diagonals of a parallelogram, they bisect each other. So BD, if we draw BD, it should pass through the midpoint O of AC, and this basically means that BOD is a straight line. So BOD is a straight line, and hence BOD is the other diagonal of the rectangle. So what we have basically concluded here is that AOC and BOD, they are the diagonals of the rectangle ABCD. Now I want to make one important remark here. The fact that BOD is a straight line, you cannot conclude it directly by looking at this figure, because in this figure, the way we drew this figure was we drew AD and then we drew CD and they intersected at D, and then we joined OD. So this does not guarantee that OB and OD, they are in a straight line. But the fact that the diagonals of a quadrilateral of a parallelogram bisect each other means that if we draw BD, that should also pass through the midpoint of AC, which is O, and hence this means that BOD is a straight line. So BOD becomes the other diagonal of ABCD. So AOC and BOD are the two diagonals of the rectangle ABCD. And the interesting thing about any rectangle is that the diagonals in a rectangle are equal. And this means that AOC must be equal to BOD. And the reason being that ABCD is a rectangle, and in any rectangle, the diagonals are equal. So AOC and BOD are equal. So their halves will also be equal. So let's write this here. So half of AOC will also be equal to half of BOD. So what is half of AOC? Well, half of AOC will be either OA or OC. So we can write both OA and OC. And what is half of BOD? So half of BOD is the other diagonal, and O is the midpoint of BD as well. So half of BOD will be OB or OD. So we can write half of BOD as either OB or OD. So from here we see that OA, OC and OB are equal, which basically means that the point O is equidistant from A, B and C. So that completes our proof for question number 6.